Hi everyone, in today's lesson we're going to talk about how to add and subtract rational expressions with unlike denominators. The first thing that we're going to try to do is factor all the denominators to try to make them the same. And then find the common denominator. Figure out what's missing, and then you're going to do the same steps just like you did yesterday to finish it. So let's look at the first example. So here, the first example, the denominators are not the same. So we know that in order to add or subtract fractions, we have to make them the same. So it looks as though that they both have a p, and this one has an m squared. So if we multiply both sides by m squared, or excuse me, the right side, we'll now get the same denominator. So this fraction is going to stay the same, so it's 2 over m squared p, and this one is 5m squared now over, and I can write m squared p because multiplication is commutative. And then I do the same thing like I did yesterday. I add the numerators and keep the denominator the same. And that's it. That's my final answer. I would try to see if I could factor anything on the top or anything on the bottom to see if I could cancel, but I can't. All right, let's look at example number 2. The first thing I notice is that this 1 over here needs to be written as a fraction. So anytime you have something like that, you can just put that number over 1. So you can clearly see that the common denominator is 4y. So I need to multiply the top and the bottom by 4y. So this fraction stays, the middle fraction stays, and the last fraction becomes 4y over 4y. So now that they all have the same denominator, I add and subtract the numerators and I keep the denominator the same. Now I can simplify this. 7 minus 3 is 4. So I have 4 minus 4y all over 4. And I think in the numerator I can factor a GCF of 4. And I'm left with 1 minus y. And the denominator is 4. So now that the numerators are attached by multiplication, and the denominator is multiplication by 1, we can cross these off, and this would be my final answer. Okay, let's look at example number 3. So I'm going to factor the denominator. So if I factor by adding and multiplying, I get m minus 3 and m plus 1. So realistically, if I write what I have n over n minus 3 plus 2n plus 2 over m minus 3, n minus 3, n plus 1. So if you see, this has an n minus 3, and so does this. This has an n plus 1, so this side needs an n plus 1. And whatever I do to the bottom, I have to do to the top. So if I distribute this out here, I have n squared plus n all over n minus 3, n plus 1, plus 2n plus 2 over n minus 3, n plus 1. So now that the denominators are the same, I could write it as one denominator and add the tops. Now I can simplify this by adding these terms to 3n. So I have n squared plus 3n plus 2 over n minus 3, n plus 1. And let's see if I can factor this numerator. Do I have numbers that add to 3 that multiply to 2? And I do. I should have n plus 1, n plus 2 over n minus 3, n plus 1. So those can cancel. And my final answer is n plus 2 over n minus 3. Okay, Last example, example number 4, if you notice, k minus n and n minus k are opposites. And we know that subtraction is not commutative. So I just want to insert a slide here and show you what happens. Okay, so I'm going to choose to multiply. It doesn't matter which side, but I'm going to choose to multiply this side by -1. So by doing so, I'm going to get negative k over, when I distribute this, remember, that's negative k plus n, which I could write as n plus k, which I could write as n minus k, and then minus k over n minus k. So now that the denominators are the same, I can write it as 1 and subtract the numerators, which become negative 2k over n minus k. Okay, so that was 4 examples about common denominators and how to make them and how to simplify them. So what I'd like you to do now is flip the worksheet over. If I have n minus k and k minus n, I have to choose which one I multiply by -1. So watch, if I multiply this by -1 and I distribute, do you agree I will get negative k plus n, which is the same thing as saying n minus k, which is over here. So I could choose to multiply this equation by -1, or I could choose to multiply this side by -1. And if I do that, I can switch it, right? I get this. So we can't switch them both. We can only switch one, because if I switched both, then these two aren't the same. So let's see how that works in this problem. Whoops. And take a look at these 4 problems and see what you can do as far as finding common denominators. The only other type of example that I didn't do with you yet was an example like number 6. So take a special note on number 6 as to how to find that common denominator, and I'll definitely be sure to go over this tomorrow in class. All right, thanks so much. Have a good night.